everybody, and welcome back to Math Extra. My name is Mr. O'Neal. I'm a math teacher at Piedmont, IB Middle School here in Charlotte. If you made it this far, you must be ready to step up your game. I love it. So, to all my 8th graders, here we go. Let's get ready to do the math on Math Extra. Hey 8th graders, this is part 2 to the Pythagorean Theorem. And so we're looking at the Pythagorean Theorem through application problems that actually happen and occur in real life. So let's get started with the lesson. So this is Pythagoras. He is responsible for the Pythagorean Theorem. He named it after himself because that's his ego. So here we are. We know that last week we said that a squared plus b squared is equal to c squared. And if you were here, I showed you these 3 shortcuts. Now, if you missed last week's lesson, I'm telling you, you need to go back and watch it because you're not going to know where these shortcuts come from. And so you really want to know where they come from because math teachers don't like teaching you shortcuts without the math. So let's look at the lesson. So today we're looking at word problems. Specifically, how do we see these word problems with the Pythagorean Theorem in real life? So the problem says a man drives 33 miles east and 12 miles south. Approximately how many miles is the man from his starting point? Now, one of the reasons why I put a compass on this actual problem is because I've realized that students have never seen a compass before. And honestly, I was like, north, south, east, west, what? Y'all don't, okay. So, I mean, back when I was a child, we had maps. We didn't have GPS, what we do right now. I'm not even that old. But I want you to realize that where north, south, east, and west is located. So let's look back at the problem. So here we have the compass. You've never seen it before. Here we are. And so when I read this problem, it says a man drives 33 miles east. So I am going 33 miles east. And where is east? If I start here, east is this direction. So 33 miles east. I'm going to say 33 right there. And then 12 miles south. 12 miles south. And 12 is right there. South is right here. So the question is asking how far is the man from his starting point? So this whole lesson deals with what? The Pythagorean Theorem. What does the Pythagorean Theorem deal with? Right triangles. What do you think we're going to do? We're going to actually draw a right triangle. So let's look at our problem. So I see that he's here now. And so I want to know where he's at. How far is he from his starting point? So what that would be a right angle right there. We learned last week that the side across from the right angle is C. So we are looking for C. C is called the hypotenuse, and it is the longest side that we proved last week of our right triangle. So what do I want to use now? The shortcut that I showed you last week. So we're looking to find the side C. Let's use the shortcut that we looked at last week. Here we go. So we know C is equal to the square root of a squared plus b squared. So what is our a squared? I'm going to call this side A. Remember, our legs don't matter, but usually the vertical leg I'll call A. I'm going to call this side B. All right, so we know that C is now equal to the square root of 12, I call that side A, 12 squared plus 33 squared. And now, this is what we're going to do. We're going to use our Math Extra calculator, and we're going to put in the square root of 33 squared plus 12 squared and see what the calculator gives us. All right, here we go. So the square root of 33 squared plus 12 squared, or 12 squared plus 33 squared, is equal to C is approximately, this is 35, and we're going to round to the nearest tenth, 0.11. This one says, hey, round that, keep that to 1. So C is 35.11 1, what are our units? Miles. All right, so Pythagorean Theorem can be found with finding distance. And now we know where north, south, east, west, where all those locations are right now, directions. And now we can look at the next problem. Let's take a look at the next problem. Ramps. If a truck ramp is 32 feet long and the top of the ramp is 10 feet off the ground, how far is the end of the ramp from the truck? So I'm going to attempt to draw a truck. Now y'all bear with me. Y'all bear with me, all right? This is my truck. Okay, here we go. So here is my truck right here. So we have a truck. We have it right here. I think my truck is looking amazing right now. All right, how y'all like my truck? Y'all like my truck? You like my truck? Okay, well, I think my truck is amazing. So now let's do the math with the truck. Okay, here we go. So the truck ramp is 32 feet long. So I know the truck is on the road, 32 feet long. So the 32 is here. That represents my truck ramp. The top of the ramp is 10 feet off the ground. So the top of the ramp is here, and it is now 10 feet off the ground. So I know that this is 10 feet. How far is the end of the ramp from the truck? So the end of the ramp would be here. From the truck is here. Okay, y'all. Do y'all see what I just did? I just modeled how to fill in the numbers from the problem. I've noticed that students get numbers in the problem and you're like, well, that looks like that's supposed to be that, and that looks like that's supposed to be that. No, my drawing is not drawing the scale. So I need us to read and actually interpret where the numbers go. It said the truck ramp is 32. That's the ramp, and it's 10 feet off the ground. It's not on the ground, so it's off the ground. So that has to be the 10. Now let's solve the problem. So the last says, how far is the end of the ramp from the truck? Y'all, the end of the ramp is right here, end. And this is the truck. So we're looking for this side right here. And what does that side represent? One of the legs. I'm gonna call that leg B. So the equation for my shortcut is B is equal to the square root of C squared minus A squared. B is gonna be equal to the square root of 32 squared minus 10 squared. We put that into our handy dandy Math Xtra calculator. We get B is approximately 30.4, what are our units? Feet. Okay, so here we have it, y'all. I can use the Pythagorean theorem dealing with a truck. I tell you, Pythagoras loved his theorem. We're going to see it all over the place. But the thing is, because math is everywhere, the thing is we have to understand where to put the numbers. So if we read the problems, we won't have an issue with where the numbers go. Let's look at the next problem. Okay, ladders. Bobby leans a 15-foot ladder against his house. The base of the ladder is placed 4 feet from the base of the house. How far up the house does the ladder reach? All right, here is my house. Watch this beautiful house right here. I have math skills and I have artistic skills. Beauty is in the eye of the beholder. All right, so we have a 15-foot ladder. Look at that ladder, y'all. Okay, 15-foot ladder. Okay, so this is the deal. Why does the 15 go where the ladder is leaning? Why is it going there? Because the ladder is 15 feet. So why would I put the 15 feet anywhere else? It goes where the ladder is. Okay, here we go. 15 feet goes there. The base of the ladder is 4 feet from the base of the house. Where's the base of the ladder? This is right here. This is my base of my ladder, right? And it is 4 feet from the base of the house. This is the base of the house right here. So it is 4 feet. Now y'all know this is not drawing the scale because we know that's not 4 feet, but we're gonna put our 4 there. And then the question is how far up. Everybody look at me real quick. Look at me real quick. There is no reason to put this up anywhere else but on the side of the house. How far up the ladder? So we don't know that. So we let that be our variable, okay? I'm gonna say that's A. So our equation is A is equal to the square root of C squared minus B squared. We can use shortcuts because Mr. O'Neal showed us the math. And so we have A is equal to the square root of 15 squared minus 4 squared. Using our calculator, A is approximately 14.5 what? Feet. Okay, so these problems become easier when we read and we place the numbers where they're supposed to go. And I know we can read the difference between away from the house, the ladder's height, or how high it is going up the house. So put our numbers where they're supposed to go. All right, so the Pythagorean Theorem, Pythagoras is crazy about his theorem, y'all. So we see it everywhere, we see it in real life, and now we're going to look at the Pythagorean Theorem somewhere else. So let's look at the next slide. All right, Pythagorean Theorem on the coordinate plane. He loves his theorem, everybody. So here we are. Plot the point -3, 6, and 2, 4. So let's be reminded, that's the x and the y. That's the x coordinate, that's the y coordinate. Plot the point -3, 6, 1, 2, 3, -3, and then up 6 would be here. I'm gonna call this point A. And then plot the point 2, 4, 1, 2, 1, 2, 3, 4. I'm gonna call this point B. All right, then find the distance between the points. So I need to find the distance between the points. So what do you all think we're going to do? What have we been doing all day? Making a right triangle. So let's make this right triangle and let's find the distance between point A and point B. Here we go. 8th graders, I know y'all got this. All right, so if I wanted to make a right triangle, I could do this. All right, I could do that. Or I could, in essence, go up this way. So I have two options for my right triangle. Doesn't matter which one I do. So if I make this my right triangle, or if I want to use this one as my right triangle right here, I am still missing the side across from the right angle, which would be C. So I need to know what the legs are. And how do we find the legs from the coordinate plane? We count them. So let's count them, y'all. All right, here we are, 1, 2. So I'll call that 2, 1, 2, 3, 4, 5. We'll call you 5. If I want to use the other triangle, 1, 2, 2. This is really not drawing the scale, y'all. And this is 5. Okay, so if I'm missing C, the formula is C is equal to the square root of A squared plus B squared. What is my A? My A would be 2 squared, plus my B squared, which would be 5 squared, and then C would be approximately 5.4, and since we don't have units, we write units. Okay, so if you use the other triangle, it will be the same thing because the side was 2 and then the B was 5, and so we will get the same answer. And so even if we need to find the distance, that's a diagonal distance, what have we learned? We can actually draw a right triangle and find that distance. And so the Pythagorean theorem, we can see it everywhere. We see it in real life. We see it in the coordinate plane. Pythagoras did us a favor by giving us this theorem that we see all over the place. Why? Because math is everywhere. Learning math starts with a teacher. Hey, that's me. And with a student. Hey, that's you. And how do we hear from you? With the Math Extra video question of the day. Let's check this question out.
Hi, my name is Aryan, and I have a question. Why can't you use the slope of the line to find the length of the line segment? Thank you.
Aryan. Man, that's a great question. And every time I present this problem, students want to find the length of that segment by using the slope, but it's different. Let's watch this, okay? look at the bottom of the screen. So we know that slope is equal to change in y over the change in x, and that's where we get our rise over run from. So if we look at the slope of this line here, I'm back over here with my line segment, I can say I'm going down 2. So the slope of the line is -2, and then that's the rise or the change in y, and the run, which is the change in the x, which is the horizontal change, is 5. So this is the deal, Aryan. Students get confused because they forget that slope represents the steepness of the line. It is not talking about the distance of the line segment. And then the negative sign is telling you what direction the line is rising in or what direction it's falling in. I like saying rising to the left. So this line is rising to the left, but the steepness of the line is 2/5. But that's not the length of the line segment. So let's look again. So again, the steepness of the line, I'm going down 2, so that's my -2. I'm gonna put that negative sign with that 2, and then to the right 5, and that's my -2 down here over 5. That's the slope. Now your question is asking, how can we use the slope, or why can't we use the slope? If we actually look in the Pythagorean theorem right here, we actually see the 2 and the 5 here. So Aryan, we are actually using the slope, but we're not using 2/5 to say that's the length of the segment. We're finding the direction. So the change in y over the change in x, which is actually giving us the length of the line, the vertical change over the horizontal change. Watch this, Aryan. So this 2 right here is represented by my slope of this 2 here, which is also here. So that is actually the vertical change. What is the vertical change looking at my picture right here? It is this change right here. And now the 5, which is right here, represents my horizontal change. Where is the horizontal change? Right there. I'm actually using the slope in this problem, but I'm not using the slope to say that the length of the segment is 2/5 or a -2/5. We are using the slope to find the distance or the change in the y's over the change in the x's. Now, Aryan, I have a bonus for you. In Math 1, we discovered the distance formula, okay? And the distance formula is derived from the Pythagorean theorem. This is what the distance formula says. This is what the distance formula is. The distance formula, watch this, is D is equal to the square root of my difference in my x's squared plus the square root, this is still under the square root, of the difference in my y's. So Aryan, we know the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Aryan, we're actually using the slope to help us find the distance between the points. It's just that we're not using the 2/5 to say that's the distance. We're using the 2, which represents the change in the y's, over the 5, which represents the change in the x's, and those numbers are my legs. So we're actually using the slope, not in the way that we're used to using the slope to help us find the distance of this point. Okay, Aryan, I hope this really helped you. I gave you a bonus, and that was extra, okay? Hey, 8th graders, I know that was a lot. We looked at the Pythagorean theorem when it came to direction. I showed you what a compass was. We looked at the right triangles from a ramp, from leaning the ladder against the house. Then we moved on to the coordinate plane. Listen, we can see math everywhere. Well, that's it, 8th graders, for this lesson of the show. And that's it for this episode of Math Extra. But you know what? The learning never stops. If you're thinking, why do I need to know this stuff? Remember this, math is everywhere, and it's part of everything you do. We're here to help you any way we can because that's what teachers do. So do your part. I'm Mr. O'Neal, and on behalf of the entire Math Xtra team, be safe and be smart, and we'll see you next time on Math Xtra.